You are watching the 6.13, the last lesson video of the quadratic functions unit. And this one is on quadratic applications day 2. So we're not doing anything differently than what we did on day 1. We are just getting more practice. Something that I do want to point out is that the Regents exam just loves to ask quadratic application questions. It's usually on every single exam, and it's not the same type of question. That's why we're practicing so much. All right, so this one here is wild. So we need to be very careful when we read this through. So a park is going to have renovations to its garden, and a garden was originally a square. Okay, so first thing, let's draw a picture of this. It was originally a square. And something happened to it. It was adjusted. So one side is doubled while the other side is decreased by 3 meters. Okay, so basically we're taking a square and we're turning it into a rectangle. Okay, so square to a rectangle, and the new rectangular garden has an area that is 25% more than the original. Okay, so this is weird. All right, so one garden, it was originally square. We don't know those side lengths, so let's just label those x. Well, all of them would be x, right? It's a square, so they're all the same side lengths. X would be the original side length of the garden. And then one side is doubled, so doubled would be twice x. And then the other side is decreased, so this one is doubled. And the other one is decreased by 3 meters. So decreased by 3 meters means we're taking away 3 meters from x. Okay, so we have to write an equation. I'm kind of writing my pictures in this spot because I don't really have anywhere else to write them. We have to write an equation that could be used to determine the length of a side of the original square garden. I mean, looking at that just seems so overwhelming. So I'm going to look at what I have here. And I know I'm talking about areas, so let's just find the areas of each of my rectangles. So the area here is length times width, which is really x times x. So area is equal to x squared. That's the original. And then here, this area is also equal to length times width, so 2x all times x minus 3. Let's just distribute it. So we get what? 2x squared minus 6x. So we have two areas. Okay. And what are we going to do with them? Well, we can compare them because the new rectangular garden has an area that is 25% more, 25% more, 25% more than 100%. So 100% plus 25. That's 125%, which if we're dealing with math, we need to write that as a decimal. So 1.25. So we know that the new will have an area that is 25% more than the original or the old. Okay, so now I write it in words. I can see that the new garden, well, that was what? 2x squared minus 6x. That's going to equal 1.25 times the old area, which is x squared. Okay, so there's my equation. Now we need to explain how our equation models a situation. Well, I'm just going to summarize what I just did in a couple sentences. Okay, so what did I do? I found the original area and then the new area, and wrote those out, and then set the new area equal to 1.25 times the old area because I wanted to make sure that I used the 25% increase, which they talked to me about. Okay, so now let's keep on going with this question. Okay, so what do we have here? We have to solve this. So 2x squared minus 6x is equal to 1.25x squared. Okay, set it equal to 0. We got a quadratic going on. How do we know this? Because we got some x squareds happening. So I'm going to take away 1.25x squared from both sides. And what do I get? 0.75 x squared minus 6x is equal to 0. Okay, both of them have an x, so let's factor out x. So 0.75x minus 6 equals 0. And let's go ahead and find our two roots. So x is equal to 0 and 0.75 x minus 6 is equal to 0. And move that 6 to the other side to get 0.75 x equals 6. And then what? Got to divide both sides by 0.75. Let's do this on our calculator. So 6 divided by 0.75 gives me 8. So x is equal to 8. So what did we find? We found the original side length. That's what this was. So what we just did was we found x, and they wanted us to find the area of the new garden. So, okay, we got to use our new garden area, which was 2x squared minus 6x. And then we're just going to substitute in what we found for x. And I'm going to use parentheses. We found x to be 8. You know, we also found x to be 0, but we can reject that. I guess we should have talked about that before I started substituting. And why do we reject it? Well, it can't make sense to have a side length of 0. That would mean that this square didn't exist. And then this problem wouldn't even make sense. So, okay, so all we have to do in our calculator is figure out what exactly the area is. And I will substitute this in exactly how I see it because I don't want to make any calculation mistakes. And our final answer is 80, and what is my unit? Meters. 80 meters squared. All right, take a minute to read question number 2. All right, so they gave us a function right here, and they told us what each one of the variables means. Down below it says Michael kicks a football, and it gives an initial upwards velocity of 50 feet per second. So above that it said that that is actually v. And the starting height is 3.5 feet. Okay, so they gave us h and they gave us v. So let's do some substituting first. So we have our equation, h is equal to negative 16 t squared plus vt plus c. And we're going to put in 3.5 for h. Everything else stays the same until we get to v, which is 50 t, and then plus c. And you know what? I am actually not being very careful because that was not h, silly Mrs. Ruscio. That was actually c. So let's fix this. We weren't even given an h yet. This 3.5 here, it says the starting height of the football, and you know what? I didn't highlight it up there. That's why I think that I overlooked it. So let's rewind. We weren't given h. We were given the starting height, the y-intercept, to be 3.5. Okay, so now it says if no one catches the football and it lands on the ground, or lands on a ground, I guess. I don't know how many different types of grounds are there. So lands on the ground, how long will the football be in the air for? So we're actually looking for a time, because how long? And we know that it's landing on the ground. So that means our h, our height, will be 0. So this is just a fancy way of saying, yo, let's solve this. And I have a decimal in here, and I can't really factor out a GCF that I know of, so I am just going to do the quadratic formula. So my A is going to equal negative 16, my B is going to equal 50, and my C is going to equal 3.5. All right, so let's go ahead and write out the quadratic formula. X is equal to negative B plus or minus the square root of B squared minus 4AC all over 2A. All right, let's rock and roll. Substitute. Pause the video. You can do this. Okay, check to make sure that you have this right. Then pause the video again and simplify. This are 3 parts that we always simplify. Then we'll check back. And hopefully you got this. And the great news is we are going to be rounding to the nearest tenth of a second, so I don't need to do any simplifying of radicals here, but I do need to type this into my calculator carefully. So I'm going to do this with you. So negative 50, let's do the positive one first. So 2724 all over negative 32. And, all right, so x is going to equal, or one of our roots is at, let's round this to the nearest tenth, so negative 0.1, and then the other one would be x is equal to, well, let's just copy and paste this, and change that to a negative, or subtraction sign, I should say, and we end up getting 3.2. So the negative doesn't make sense because we can't have the football in the air for negative seconds. So in this case, our final answer would be 3.2 seconds. And just to be thorough, I ended up using the check on my calculator to make sure that my 2 values were the same and that I didn't make any mistakes substituting. So I have confirmed that my answer is correct. All right, heading on to 3. So Tamara has 2 sisters. One of the sisters is 7 years older than Tamara. The other sister is 3 years younger than Tamara. And the product of Tamara's sisters' ages is 24. How old is Tamara? Okay, so let's say x is equal to Tamara's age. And she has 2 sisters. One of them is 7 years older, so x plus 7 is the older sis. And the other sister is 3 years younger, so x minus 3 is younger sister. Okay, so immediately we need to write out let statements. We cannot start a problem like this if we don't even have a variable labeled. Like if I start using x's and I don't say what it is, I'm going to assume that it's monkeys in the zoo, and we don't want to do that. We're dealing with Tamara or Tamara, however we say it, her age. Okay, the product of her sister's ages is 24. So we need to write an equation now. Notice how we should be using parentheses. You may even want to include them up here. We're multiplying these, and that should equal 24. Okay, now some of you might want to set both of these equal to 24 and be done with it. That is not how this works. We have to get this set equal to 0, or at least double distribute to see what's going on over here. So however you double distribute, it doesn't matter to me. If you wanted to show the box method off to the side, that's okay too. Some of you are getting really good at doing this mentally. That's also very good. Whatever method works best for you. But we should get x squared plus 4x minus 21 equals 24. Yep, we got a quadratic. There's some x squared business going on here. Let's subtract 24 from both sides. I'm going to swing this on up over here. So x squared plus 4x minus 45 is equal to 0. Now we can try factoring it. I think this actually works. So if you need to factor using the box method, go for it. Some of you are like, wait, 9 times 5 is 45, and then if we subtract them, 9 minus 5 would give me 4. So yay, there is my factored form. And you got it. X plus 9 equals 0, x minus 5 equals 0. So if we move our constants to the other side of the equation, we get x equals negative 9 and x equals 5. We don't want the negative because we can't have negative ages. Tamara cannot be negative. So Tamara is 5 years old. Okay, why don't you take a second to try to set up question number 4 on your own and then check back with me. Okay, here are my let statements. Notice that we always set x equal to the first one, and because we were dealing with consecutive positive even integers, the next one would have to be x plus 2 because we're counting by 2's, and then add another 2 on, so that's where x plus 4 comes from. All right, set up that equation. Try it on your own. Pause the video. Okay, so the product, we're multiplying the second and the third. That should equal 10 times the first, and then 20 more than that. I color-coded it for you. Now what do? Well, we got to do some multiplying, so some double distribution. Go ahead and try solving this one on your own. All right, so here is the solve. Notice how at the end I got, and hopefully you got, a positive x and a negative x. But going back to the original question, we're trying to find consecutive positive even integers. So that negative 2 goes by. And my 3 integers would be 6, and add 2 onto that, we get 8. And add another 2, we get 10.